Hello there. In this video, we are going to get introduced to AWS's Identity and Access Management, or simply IAM service. This is one of the most important topics of this course. We have already seen the overview of the different services that AWS offers, such as compute, storage, and database related services. The user of these services would be creating a very high number of resources for their infrastructure. So, one might ask, how do I manage the security of these resources? In other words, how do I give or manage the access to all my resources to the entities that are internal as well as external to my organization? Well, IAM gives you the answers to all these questions. As shown on your screen, IAM involves quite a lot of features and concepts. We will be going over all of them in subsequent videos. So what is IAM then? IAM is a web service that enables you to manage the access to the AWS services and the resources securely. Note the word securely here. It helps you control who is authenticated and authorized to use these services and resources. Authentication basically means who is allowed to sign in or access the resources, and authorization means what type of access the entity or the user will have after signing in. IAM is used by virtually every AWS service, and it actually integrates very well with all the other AWS services. It is very important that you clearly understand all these concepts. It will not only help you pass the associate level exams, but it will help you grasp the more advanced concepts when you will study for the professional level exam. Finally, IAM is a feature of your AWS account that is offered at no additional charge. But you will be charged for the use of all the other AWS services by your users. Just keep that at the back of your mind. To illustrate this concept, let us take an example of an organization that has different departments such as software development, legal, finance, travel, etc. Each department has personnel working for them with specific duties or roles. For example, software development department will have software professionals, legal department will have lawyers, and finance will have financial experts, etc. Now, in this organization, software professionals will have access to the code base and database servers, but are unlikely to have access to the legal documents and sensitive financial data. Similarly, lawyers will not have any access to the code base or any servers or any financial documents. It is also least likely for the financial experts to have access to the legal documents such as lawsuits or contracts. They should have access to the financial data only and nothing related to the other departments. At least let us assume so in this example. How do this organization achieve such separation of access? This intricate access management is done via creating specific roles. In other words, certain type of access is only given to individuals who have a certain role. Now let's go one level deeper. Let us say that the software development department consists of coders as well as infrastructure engineers. It would make sense that not all software personnel would have full access to all the resources, such as the code base or servers. Bob, the programmer, may have write access to the code base but may have only read-only access to the production server. Whereas Stacy, the infrastructure engineer, may have write access to the production server but no access to any of the code base. Despite both being software professionals, they have different level of access. How are they given such different access? It is done via permissions. In other words, despite having the same role of software professional, some personnel or users will have different permissions than others. In this example, if for some reason Stacy needs a read-only access to the codebase, all the system administrator would have to do is change the permission for Stacy from deny to read-only access. Simple. Now let us come to the AWS world. The codebase, servers, legal, and financial documents, all of them are the examples of resources. The personnel that we talked about, such as Bob and Stacy, are the IAM users. IAM users encompass not only the human beings but also applications, such as computer application or mobile application. The group of software professionals where they had common access or permissions is an IAM group. The particular role, such as programmer or infrastructure engineer or even software professional, all of these are nothing but IAM roles. And finally, being able to fully access the code base or not being able to access the server or being able to access the server as read only. All of these examples are of permissions which you define using what is called as IAM policy. IAM policy is written in JSON, that is JavaScript Object Notification. Before we get to the AWS console and start exploring different IAM options, let us look at some of the prime features of IAM. First, IAM lets you securely manage the access to AWS service and your resources. It allows you to create principals such as users, groups, roles in order to have the strict, granular, and most importantly, secure access to your resources. It allows you to define policies in which you allow or deny the access to the resources. It also supports identity federation for delegated access to the AWS Management Console or AWS APIs. This is a very interesting topic and we are going to cover it in detail later in the course. It also provides multi-factor authentication protected access, which we'll see in the next lab. And finally, it provides a policy simulator which allows you to view the policy and its outcome before you apply it in the production environment. In the upcoming lessons, we are going to dive deep in these and more such IAM concepts and their features. For that, you will have to sign in into the console using your root account. I will see you in the next lab. Thank you. In this video, we are going to get started with using identity and access management, that is IAM service. For that, you have to sign in into your root account. Before we go to the IAM service, I want you to pay attention to the AWS region that is currently set. For me, it is Ohio. For you, it may be different, but it really does not matter. Just remember the name. Now, let us go to the IAM service, which is under the Security, Identity, and Compliance group. Now, take a look at the region. It is changed from Ohio to global. Just click on the arrow and you will come to know why that is. As it says, IAM does not require a region selection. In other words, IAM is a global service and all the IAM resources created under your account would be accessible across all the regions. This is a very important point that you must remember. Let us look at the different parts of the IAM service console. Just below the welcome message, there is a sign-in link provided by AWS for IAM users to sign in. You might ask, hey, I can just go to aws.amazon.com/console and should be able to log in using my email address and password. Why should I use this link? This is a perfectly valid question. The reason for providing this link is that you have logged in using the root account credentials. This current user has all the administrative privileges with unrestricted access. Just like any Windows or Linux user, as a security best practice, you should avoid signing into the account using the root credentials as much as possible. Once you create the root user, you should always create individual users and assign them only the required privileges. Once you create the IAM users and set up their password, you can provide them with this link to sign in into their console. We are going to see how this works in just a few minutes. The important thing to remember here is that this number is nothing but your account number. Since it is too difficult to remember the sign-in link, you can customize it using the Customize option and creating an account alias. Let us create an alias as vizcsaa. Notice that I have given all capital letters. You will have to give some unique name and click Yes Create. As soon as we do that, it will show you an error. The specified value for account alias is invalid. It must contain only digits, lowercase letters, and hyphens, but cannot begin or end with a hyphen. So, we should go ahead and change it to lowercase account alias. Just click Yes Create, and there you go. It has renamed the link. Perfect. The section below the sign in link is a summary of IAM resources. That is, it shows how many users, groups, customer managed policies, roles, and identity providers are created under this account. Note that these options are same as the ones on the left side panel or the menu. If I click on users, it basically takes you to the same users page. If you click on the dashboard, it should take you to the home page of the IAM service. The security status indicates whether you or your users are following the best practices about securely accessing and maintaining the AWS account. An exclamation point indicates that this particular area is potentially unsecurely configured and can further be fortified. It is suggesting you to follow some AWS recommended best practices. So let's go ahead and set these straight. First, it is advising you to delete the root access keys. It is important to do so because the access keys, if fallen into wrong hands, would give them unrestricted access to your account. It is already showing you the green checkbox because either the access keys are not created or they are already deleted. But if we had created and not yet deleted them, it would show you the exclamation mark instead. So go ahead and click on Manage Security Credentials. Just hit continue. It will take you to the Security Credentials page. Note that this page is also listed under the root account or the current user's setting page. When you created the root account on AWS, if you did not set a strong password, you can do so using this option. Since I have already set up an uber strong password, I am going to skip this. We are going to set the multi-factor authentication or MFA in just a few minutes. Let us skip that as well. The fourth and fifth options, that is CloudFront key pair, which is used for creating signed URLs, and X509 certificate that is used to make SOAP or Simple Object Access Protocol requests to AWS services, are not really required for the associate level certification exams. We will be covering the signed URLs as part of CloudFront in a separate video. So for now, let us skip these two options as well. The last option is account identifiers. It shows you your 12-digit AWS account ID and a canonical user ID, which is basically used for configuring the S3 access control lists. The details will be covered in the S3 section. The most important thing is deleting the access keys. We do not have any active keys because I had deleted them already. If you do not see any, just don't worry about it. We can create them by clicking on the Create button. It prompts you with the message saying that your access key, which is a combination of access key ID and secret access key, has been created successfully. So you can view the keys by clicking on this option, as well as you can download the key file which stores the same access key ID and the secret access key in a CSV file. It is important that you store this file in a safe place. You will need these keys in order to access the AWS services via API or CLI. Let's hit close. Now, since the keys are not yet deleted because we have one active key here, let us go to the home page just for a second. Click on the dashboard. As you can see, it is showing you an exclamation mark indicating that there is a security loophole with these settings. So let us go back to the setting page, manage security credentials, hit continue, go to the access keys and just delete the key. Say yes. So we have deleted all our active keys. So if you go back to the dashboard, the exclamation mark gets converted to the green checkbox. Well done. Now let us set up the multi-factor authentication or MFA on our root account. Let us first see what MFA is about. MFA is basically just a mechanism to add an extra layer of security. So what it does is when the user accesses the AWS websites or services, it requires the user to type a unique authentication code from an approved authentication device. Let us see how that works. Click on Activate MFA. Just hit Manage MFA. You can select either a virtual or a hardware MFA device. If you click on the given link, it shows you all the supported MFA devices. For our lab, we are going to use a virtual MFA application that is Google Authenticator. Before you proceed any further, please pause the video and download the Google Authenticator app. Once you download the app, just open it and it should look something like this. Click on the Begin Setup option. It then asks you to either scan the barcode or add an entry manually. Touch on the Scan Barcode option. Now, in your AWS console, select a virtual MFA device and click Next. It says to activate a virtual MFA device, you must first install AWS MFA compatible application, which we have already done so. Just hit Next. At this stage, please scan the barcode using your smartphone or the mobile device. Once you do that, your device will show you a 6-digit code that you need to put as the authentication code 1, and immediately it will give you another 6-digit code that you need to put as the authentication code 2, and then click Activate Virtual MFA. Once you finish, it will show you this message. Now click Finish. Sometimes AWS console may not acknowledge the MFA success immediately. For that, either refresh the page or click on the dashboard again. And it should show you our second green checkbox. For the next two security related items, we will have to create IAM users and IAM groups and assign permissions to them. We will do that in the next video. See you there. In this video, we are going to learn and create IAM users and IAM groups. In the introduction to IAM video, we saw the example of users, that is Bob the programmer and Stacy the infrastructure engineer. We also had groups such as software professionals, legal experts, and finance experts, etc. For our further understanding, we are going to create IAM users, IAM groups, and IAM policies as shown here. We will first create IAM users, Bob and Stacy. Then we'll add another new user, Joey, the financial analyst. Then we will create two groups, software professionals and finance experts. Since all the software professionals need access to the servers, say the production server, that is RDS or relational database systems, we will create the policy and attach to the software professionals group. Similarly, we will create and attach the policy that will give the finance experts an access to the documents that are stored in S3. Bob is a programmer and needs access to, say, all the virtual machines like Linux or Windows. So we will attach the EC2 access policy to Bob only. So let us go ahead and create those. For that, you will have to sign in into the AWS console. Here we are in the AWS console logged in as the root user. Currently, we neither have any users nor any groups created. Once we create them and assign the appropriate IAM policies, the next two exclamation marks will magically become green. First, click on Users and then Add User. Enter Bob as the username. You can add another user right here. But since we are going to assign different policies to different users, we will create the users Stacy and Joey separately. Here, you can select the type of access. With programmatic access, the user can access the AWS services via API, CLI, SDK, and other development tools. Note that for this, the user will have to use the access key ID and the secret access key. You can also allow or deny the console access, and the user can access the console using their password. Let us select both. Since we are giving the console access, let us create a password as well. I will select the auto-generated password, and I am going to enforce the user to create a new password after signing in, and because of that, Bob will automatically get assigned the IAM user change password policy to allow him to change his password. But before that, let me show you an important point. Just unselect the required password reset checkbox for a moment and click Next. Without making any change here, just click Next to review the settings. It shows a big warning. The user has no permissions. This is a very important point. When you create a user or a group, by default it does not have any permissions. In other words, the user possesses a default deny permission on any AWS resources. It is the responsibility of the administrator to add only the required permissions and remove those permissions as soon as they are not needed. Now let us go back to our previous screen. Select Require Password Reset checkbox and click Next. This screen gives you three options. You can add this user to an existing group or create a new group. You can also copy permissions from an existing user or attach existing policies directly. As per our conceptual diagram, the EC2 access policy is to be added to Bob directly. So let us attach an existing policy directly to Bob. Now, we can either use an existing policy out of many provided by AWS or create a new one. As we cover different topics in our course, we will be creating many custom policies. For our case, let us use an existing policy. Since Bob needs an access to virtual machines, let us assign him the EC2 full access policy. So go to this search box and type EC2 and select Amazon EC2 full access. As the description mentions, this policy provides full access to Amazon EC2 via the AWS Management Console. Click Next. It will give you the overview of what we configured so far. We created a user Bob. We gave him both programmatic and the console access. The password will be auto-generated the first time, and he will have to reset the password upon the first login. The policy that we assigned is Amazon EC2 full access, and by default IAM user change password policy was assigned as well. Finally, click Create User. And there we go. We have successfully created our first user. Clicking on this arrow shows you a list of events that took place as part of the creation. You can also see Bob's access key ID and also view the secret access key and password if you wish so. And you can send the login instruction to Bob via email. The same information is saved in a CSV file which you can download using this option. Finally, using this link, Bob can sign into the console and access the services based on the attached policy. Remember that this link is the same as the one given on the dashboard. Since we need the password and login, just write down this password. In your case, this string will surely be different, so note it down. Click Close. Now go to the dashboard. You can see the number of users is now 1. And we have our third green checkbox. Now let us log in using Bob as the user. Copy this link and paste it in a new browser. You can see that it automatically selected our account alias WizCSAA. Put Bob as the username and enter the copied password. Just in case you forgot to copy the password since we copied the link, I have listed the steps below that you can follow and get the new temporary password. Then use the same login link and enter the password. Hit enter. Bob now should be successfully logged in. At the top right of your screen, you can see that the current user is Bob at your root account. Note that even though you can see different services available here, Bob only has access to the EC2 service. If Bob attempts to access, say, S3 service, he is going to get an error access denied. Bob cannot create any S3 buckets. But if he goes back to the services and select EC2, Bob has access to all the EC2 instances related information and in fact can go ahead and create EC2 instances. So just for our example, let us just go ahead and create an EC2 instance. Select an AMI, just hit review and launch and hit launch. Create a new key pair, give a name, download the key pair and click launch instances. And there you go. Bob was successfully able to launch an EC2 instance. Now we are going to go over all these details later in the EC2 section, but I just wanted to show you an example where our EC2 access policy has given the permission to Bob to create the EC2 instances. Let us go back to the console home. Now we should create our remaining users, Stacy and Joey. For that, you will have to log back into your root account. Here we are in the root account. Let's go to the IAM service. Go ahead, click users, add user, give the username Stacy. We can add another user here, and that would be Joey. Assign both permissions. Now for Stacy and Joey, I'm going to give them a custom password. And let's remove this checkbox for now. Click next. Neither of them have any policy associated that is exclusive to them, like Bob. So just click next. Click create user. Now before that, note that both Stacy and Joey have programmatic and AWS Management Console access, but the console password type is custom, not auto-generated, and the required password reset is set to no for them. Click on create users, and there you go. Stacy and Joey, these two users have been created successfully. Click close. Let us view the IAM user properties in detail. Click on Bob. It shows the summary. First, it shows you an ARN. ARN is Amazon resource name, and every single resource created on AWS platform must have an ARN associated with it. As shown on your screen, the format of the ARN consists of ARN, the keyword, followed by partition, service, region, account, and the resource name, all separated by a colon. The ARN is the keyword which is always there. The partition, it basically identifies the partition to which the resource belongs. For the standard AWS regions, the partition is AWS. But if you have the resources in any other partitions, the partition would be AWS hyphen the partition name. For example, The partition for the resources in the China or the Beijing would be AWS-CN. The service basically identifies the AWS product. For the IAM resources, it will always be IAM. The region, as it says, is the region to which the resource belongs. For the IAM resources, it will always be left as blank. Can you guess why? Yes, because IAM is a global service and there is no particular region associated with IAM. The account actually represents the 12-digit account ID without any hyphens. And finally, resource is the portion that identifies the specific resource by name. In our case, it's Bob. As noted here, you can use ARNs in IAM for users, groups, roles, policies, instance profiles, virtual MFA devices, and server certificates. Below, you can see some of the examples of the ARNs or different type of IAM resources. For the associate level exam, even though there may not be a direct question asking you to write the ARNs, it is extremely useful to know how ARNs are written because you need them in writing or creating the IAM policies. So this is an important point to remember. You can optionally set the path using CLI or APIs, that is command line interface or application programming interfaces. The path here is like a hierarchical representation, a folder-like structure. Right now, Bob is created directly under the users. Hence, the path is user/Bob. You could use the nested path such as /software division /testing subdivision /cloud product to match your company's organizational structure. You can find more information on ARN, path, and unique IDs over here. Now, one might ask a question, can I rename an existing user? The answer is yes, but not via the console. At least not during the time of this recording. You need to use AWS CLI or API to do so. If you click on this help icon, you will get more information on this topic. It mentions about the CLIs and the APIs used for listing, renaming, and deleting an IAM user. On the summary tab, just below the path, there is a creation time, and below that, there are 4 tabs. Let's look at them. The permission tab shows you the policies that are attached directly to the user. We have created 2 policies. One is Amazon EC2 full access and IAM user change password, which actually was created by default. Now we are going to get into the details of each policy in our next video, but it shows you what the policy is all about. The next tab shows all the groups to which this user, that is Bob, belongs to. Currently, Bob is not part of any group. In the next tab, you can manage the security credentials of the user. Remember when we were logging into the AWS console using Bob as the user, if we had forgotten the password, what we could have done is come back to the root account, go to the users, select the particular user, go to the security credentials and do manage password. Once you click on the manage password, it will give you the options to enable or disable the console access, set the password, so you could click on the auto-generated password, and once you apply, it would give you another temporary password, which you can use to log in into the AWS console. Apart from password, it again gives you the console login link, which is also given on your dashboard, the last login information, whether to assign the MFA device to this particular user, or select the sign-in certificates for the secure login. Along with that, it also gives you the option to create the access keys for this particular user, which we already have. And you can see that this particular access key is currently active. As an additional security measure, you can go ahead and make this key inactive. In the further advanced settings, you can upload the SSH public key for this particular user for AWS code commit service. We are not going to go in detail of this topic as this is more of an advanced topic. The last tab is Access Advisor. It basically shows the service permissions that are granted to this user and when those services were last accessed. You can use this information to revise your policies. So our user Bob currently has full access to EC2. So the user would be able to access the information on EC2, Elastic Load Balancing, Auto Scaling, and Amazon CloudWatch, out of which the EC2 and ELB information was last accessed today. Now is the time to create our groups. It is very simple. Click on Groups, create a new group, give the name Software Professionals. Remember that there is no space allowed. If you click on Next Step, it is going to give you an error. So let us remove that and click Next Step. Now, just like we attached the policy to individual user Bob, we can also attach policy to the group. Let us assign the DynamoDB full access policy to our group. Click Next. On the Review tab, it is going to show you the group name and the ARN of the group. Click Create Group. And that's it. The group is successfully created. Similarly, we can add our next group, that is Finance Experts. We are going to assign them the full access to S3 service. We have now successfully created our groups. Since we have already attached the DynamoDB access policy to Software Professionals group, let us add Bob and Stacy to it. To do that, click on Software Professionals, click on Users, click on Add Users to Group, select Bob and Stacy, and hit Add Users. Similarly, let us put Joey in the finance groups. So we go back to Groups, select Finance Experts, and add Joey to it. With this configuration, all the policies that are attached to a particular group will get applied to all the users to it. If you see the properties of Bob, and for that, let's go to Users and click on Bob. There are total 3 policies that get applied, 2 of which were added to him explicitly or directly, and 1 as a result of being in a group. And as a result of that, if you click on Dashboard, we have our 4th green checkbox. In the next video, we are going to learn about IAM policies. See you then. In this video, we are going to learn about IAM policies. A policy is an entity in AWS that, when attached to an entity or resource, defines their permissions. Many students get confused between permissions and a policy. Remember that policy contains permissions which determine whether the request is allowed or denied. Policies are stored in AWS as JSON documents. Policy is attached to either principals that are users, groups, or roles, or to resources such as S3 bucket. Let's take a look at this example. Let us say an EC2 instance, an IAM user, and a role for an external user or a service, all of them need to access an S3 bucket. You need to define or use existing IAM policy that would allow them the needed access. There are primarily 2 types of policies, an identity-based and resource-based policies. Let's look at identity-based policies first. Identity-based policies are the policies that you can attach to a principal or an identity, such as an IAM user, role, or group. These policies control what actions that identity can perform on which resources and under what conditions. We saw the example of these in our previous video. Identity-based policies can further be categorized into managed policies and inline policies. Managed policies are basically standalone identity-based policies that you can attach to multiple users, groups, and roles in your AWS account. The managed policies created and managed by AWS are AWS managed policies, whereas the ones that are created and maintained by AWS users are the customer managed policies. Note that the customer managed policies provide more precise control over your policies than AWS managed policies. You can create and edit an IAM policy in the visual editor or by creating the JSON document directly. The inline policies are the policies that you create and manage and that are embedded directly into a single user, group, or a role. We are going to see the example of both in just a few minutes. On the other hand, the resource-based policies are JSON policy documents that you can attach to a resource such as an Amazon S3 bucket. These policies control what actions a specified principal can perform on that resource and under what conditions. Resource-based policies are inline policies and there are no managed resource-based policies. In our previous example, instead of attaching the policy to the principal or identity, the resource-based policy containing the principal information would be attached to the resource itself. Let us start with the template of an IAM policy. A typical IAM policy in JSON format looks like this. For those who are new to JSON, it is JavaScript object notation. It basically contains key value pairs. So a key in a double quotes, a colon, followed by its value in double quotes. First, it contains version, which is an optional policy-wide information. It contains one or more statements, which include an effect that denotes whether the policy allows or denies the access, an action, which represents the list of actions that are allowed or denied, the resource, especially in the identity-based policies, the list of resources on which the actions can occur. It typically contains the ARN or Amazon resource name of the resource. The principal, in case of resource-based policies, it represents who is granted the permission. And finally, condition, which is nothing but circumstances under which the policy grants the permission. Let's have a look at an IAM policy with multiple statements. An important point to remember is that if a policy includes multiple statements, AWS applies a logical OR across the statements at evaluation time. If multiple policies are applicable to a request, then AWS applies a logical OR across all the policies at evaluation time. In this example, we have a policy that contains multiple statements which has different effect, action, and resource mentioned in it. Note that SID represents a statement identifier. Each individual statement would have a SID in it. The asterisk represents wildcard match. In this example, changing of a password, this particular action will be allowed for all the resources. Whereas in this particular example, it allows the resources to list everything that is bucket or objects as well as get everything that is get bucket or get objects for all the resources. Now, one might ask a question, what if a user or a group or even a resource has a policy that contains conflicting permissions? Or what if the attached multiple policies contain conflicting permissions? For example, if one policy allows an access to S3 bucket whereas the other policy does not, what happens then? Well, the answer is given by a policy evaluation logic. Let's take a look at it. First of all, remember that all requests are denied by default. That is, if a policy does not mention any effect whether to allow or deny, the request is denied by default. This is called a default deny effect. After evaluating all the policies and their permissions, if there is any explicit deny effect, in any of the policies, the final decision is deny. No further evaluation is required, no questions asked. If there is no deny, then it checks if there is any explicit allow mentioned as part of the policy permission. If there is an allow, then the final decision becomes explicit allow. However, if there is neither any deny nor any allow as part of the policy, the final decision becomes deny, which is the default deny. In other words, all requests are denied by default. An explicit allow overrides a default deny, whereas ultimately explicit deny overrides explicit allow. This is very, very important to remember going into the exam. In the associate level exams, there could be questions such as they would give an example of a policy and they would ask the final effect of it. You need to carefully take a look at the policy, evaluate all the conditions in it, and always remember this sequence. First, look for the explicit deny, then look for any explicit allow, and if none of these are present, then the final effect becomes a deny. Now let's go ahead and create some policies in the AWS console. Here we are in the AWS console. Click on IAM, then go to Policies. First, I want you to click on the policy type filter. Select AWS Managed. All the policies that are listed here are AWS Managed policies. Search for S3 Full Access. Select and expand it. Click on Policy Summary. This policy allows unconditional full access to all the resources on S3. Let us look at its JSON. The version of this policy was created by AWS. It contains a single statement which allows any action on S3 for any resource. Remember that the asterisk denotes any or a wildcard entry. This is a simple policy, and some of the policies can get really long and esoteric. But not to worry. The basic important sections remain the same: effect, action, resource, and condition. And for resource-based policy, the principle is more important. Click on the filter and select Customer Managed Policy. Currently, we have none. So let's go ahead and create one. Click on Create Policy. Note that this is the same option that creating an inline policy gives for each IAM principle. You can either create a policy using the visual editor or write the JSON directly. Let us see the visual editor option first. For this illustration, we are going to create a policy that gives read-only access to buckets in S3. So first select the service to which the access is needed. In our case, it is S3. We do not want all the actions, only the read-related ones. So select Read. You can expand and view which all actions would be allowed. In Resources, it says you choose the actions that require the bucket resource type, which is what we wanted. You can click it and select bucket or object or all the resources. We want to give access to all buckets, so select any. Note that if the access was requested for a particular bucket, you would add the ARN of that bucket over here. We are going to give unconditional access, so no conditions to be specified under request conditions. Click Review Policy. Let us call it Viz S3 Read-Only Access. Give a description, verify the summary, and hit Create. Now you can see that our customer managed policy is created successfully. Click on it. You should now be able to see the JSON containing all the elements of the policy. You can edit the policy using this option, and you can edit the policy either via Visual Editor or JSON. In the policy summary, you can verify that via this policy, we have given an unconditional read access to all the resources on any S3 bucket. With this option, you can attach certain entities to this policy. With entities, I mean certain users or groups. If you click on Attach Entities and click on Attach, it will show you the list of all the users and groups in our system. You can select one which you want and click Attach Policy. It shows you that two entities were attached to this policy. That means this policy will be applied to both Bob as well as all the users that are in Finance Experts group. Let us go back to the dashboard. Now let us go ahead and apply an IAM password policy. Creating the IAM password policy forces the IAM users to create strong passwords and rotate them regularly. Click on Manage Password Policy. Note that this is the same option that is given by Account Settings on your left. This page says, currently this AWS account does not have a password policy set. You can specify one below. So let us set some requirements. You can enforce the users to include letters of certain case or numerical values or even special characters in the password. Some of the other options include enabling the password expiration after a certain number of days, prevention of password being reused, as well as password expiration requiring the administrator reset. Choose whichever option you want and click Apply Password Policy. It says successfully updated the password policy. Below that, you can enable additional regions from which you can request the temporary credentials. Currently, all regions are active. You can deactivate them if you choose so. I will just let it stay as is. Now, if you go back to the dashboard, guess what? We have all the security status icons as green checkbox. Well done. In this video, we dive deep in learning IAM policy. We also learned about different types of IAM policies. We learned about how the policy evaluation logic resolves the conflicting permissions in a policy or among multiple policies. And at the end, we saw how to create a customer managed policy. I hope you learned quite a lot about IAM policy in this video. I will see you in the next section. Thanks. When I was a kid, I used to love watching Bugs Bunny. In one of the episodes, it just wore a Superman cape and suddenly became the Super Bunny. It could fly and do all the super stuff that a Superman could do. And when the cape was taken off of him, it would become a poor old bunny. I used to find it funny and at the same time very fascinating. You might be asking, what does that have to do with the IAM roles? Well, we shall see. But just to give you a heads up, this video is all about that Superman cape. In this video, we are going to learn about IAM roles. And this is by far the most important topic under IAM. Before we start creating and using IAM roles, let us first look at some of the basics of what IAM role is and why and where it should be used. In our previous videos, we created IAM users and attached policies to it to determine what it can and cannot do in AWS. In order to access the service or resources, the user had to use their long-term security credentials such as access key ID. However, instead of being uniquely associated with one person, a role is intended to be assumable by anyone who needs it, and that may include an EC2 instance or an IAM user or a mobile application, etc. In other words, just like whosoever wears that cape becomes a Superman, even though temporarily, in IAM you define a hat and whoever wears it gets to perform the actions of that role. A role does not have standard long-term credentials, that is password or access keys associated with it. Instead, if a user assumes a role, Temporary security credentials are created dynamically and provided to the user, making them a more secure way to grant access. This is a very, very important point to remember. The temporary security credentials are created dynamically and provided to the user, making them a more secure way to grant the access. So, who all can use the role? You can use roles to delegate access to users, applications, or services that don't normally have access to your AWS resources. For example, you might want to grant users in your AWS account an access to the resources they don't usually have, or grant users in one AWS account an access to resources in another account. Or you might want to allow a mobile app to use AWS resources, but not want to embed AWS keys within the app where the keys can be difficult to rotate and where users can potentially extract them. Sometimes you want to give AWS access to users who already have identities defined outside of AWS, such as in your corporate directory, or you might want to grant access to your account to third parties so that they can perform an audit on your resources. Let us take our previous example. An EC2 instance, a user, and an application, all of them want to access S3 bucket. Instead of creating a user and giving them permanent credentials like password and access keys, it is very highly recommended that you create a role, assign the required permissions via policy, and let each of them assume that role. Now the question is, why should we do that? Or what are we going to achieve by doing that? Well, first of all, it allows you to delegate access with defined permissions to trusted entities without having to share their long-term access keys. This is a critical point that you should always remember. Also, when the entity such as EC2 accesses AWS resources such as S3 via IAM user, the user's security credentials get stored on that EC2 instance. This is a big security threat and it should be definitely avoided. On the other hand, when the same EC2 instance assumes a role, its credentials are not stored, making it the most secure way of accessing the resource. We are going to see this during the videos on EC2. Now, let us look at some of the scenarios in which IAM roles should be created and used. It is recommended to use the role when you wish to provide access for services offered by AWS to AWS resources. You should also be using roles when you wish to provide access for an IAM user in one AWS account that you own to access the resources in another account that you own. You should also consider using roles when you wish to provide access for externally authenticated users via Web Identity Federation. And finally, you should use IAM roles when you wish to provide access to IAM users in AWS accounts owned by third parties. Before we get to the console and create a role, let us get familiar with some of the terms and concepts related to IAM roles. A role is a set of permissions that grant access to actions and resources in AWS. These permissions are attached to the role, not to an IAM user or group. AWS service role is a role that service assumes to perform actions in your account on your behalf. So when you set up most AWS service environments, you must define a role for the service to assume. This service role must include all the permissions required for the service to access the AWS resources that it needs. An AWS service role for an EC2 instance is a special type of service role that a service assumes to launch an Amazon EC2 instance that runs your application. This role is assigned to the EC2 instance typically when it is launched. AWS automatically provides the temporary security credentials that are attached to the role and then makes them available for the EC2 instance to use on behalf of its application. AWS Service Linked Role is a unique type of service role that is linked directly to an AWS service. Service linked roles are predefined by the service and include all the permissions that the service requires to call other AWS services on your behalf. Going into too much details is not intended for this course, but for more information on this, please refer to this web page. Role chaining occurs when you use a role to assume a second role through the AWS CLI or API. For example, assume that user 1 has permission to assume both role A and role B. Additionally, role A has permission to assume role B. You can assume role A by using user 1's long-term user credentials in the assume role API operation. This operation returns role A's short-term credentials. To engage in role chaining, you can use role A's short-term credentials to assume role B. Again, this concept may not appear in the associate level exam, so we are not going to go into too much details at the moment. This might just confuse you more than, understanding the concept. So we'll move forward. Delegation is the granting of permissions to someone to allow access to resources that you control. Delegation involves setting up a trust between the account that owns the resource, that is the trusting account, and the account that contains the users that need to access the resource, that is the trusted account. Federation is nothing but creation of a trust relationship between an external identity provider and AWS. Users can sign into a web identity provider such as Amazon or Facebook or Google or any ID provider that is compatible with OpenID Connect. Users can also sign in to an enterprise identity system that is compatible with security assertion markup language, that is SAML 2.0, such as Microsoft Active Directory Federation Services. When you use this OpenID Connect and SAML 2.0 to configure a trust relationship between these external entity providers and AWS, the user is assigned to an IAM role and receives temporary credentials that enable the user to access your AWS resources. This is a very important topic and we are going to cover this in detail later down this course. A trust policy is a document in JSON format in which you define who is allowed to assume the role. Permissions policy is a permissions document in JSON format in which you define what actions and resources the role can use. We have seen this in our previous video on IAM policies. Principal is an entity in AWS that can perform actions and access resources. A principal can be an AWS account root user, an IAM user, a group, or a role. And finally, role for cross-account access is granting access to resources in one account to a trusted principal in a different account. At this moment, you might be feeling very overwhelmed with all the concepts and definitions. Please do not feel so. We are yet to get even to our first service. Once we start exploring services like S3 and EC2, you will find these concepts very easy to understand. Let us go ahead and create our first role. For that, please log in into your AWS console using root account. Here we are into the console logged in as root. Click on IAM and then on roles. First, it is showing you some of the existing roles. On this section, you can see some basic information and useful links pertaining to IAM roles. Click on Create Role. As we mentioned before, that IAM roles provide access for services offered by AWS to AWS resources. Provide access for an IAM user in one AWS account that you own to access resources in another of your own accounts. It also provides access to IAM users in AWS accounts owned by third parties and provide access for externally authenticated users via Identity Federation. Let us now create a role for the example that we previously used, where an EC2 instance needed an access to S3 bucket. First, choose the service that will use this role. For us, it is EC2. Just go ahead and select that. Click Next. It shows you some AWS managed policies. For our purpose, we need S3 full access policy. So go ahead and search for that. Select it and click Next. Let us call this role as Viz S3 full access for EC2. It shows some default role description. You can either edit it or keep as is. You can see that the trusted entity is an AWS service that is ec2.amazonaws.com. The policy attached is Amazon S3 full access. Click Create Role. And you can see our role is created and available for our use. To test this, let us go to EC2 service. Don't worry about the rest of the information for now. Go ahead and click Launch Instance. Select the first AMI. Click Next, Configure Instance Details. There are quite a few configuration options here. Don't worry about them for now. Just pay attention to this section, IAM role. Here we can see that our role is available for selection. If we select this role and click Review and launch the instance, this EC2 instance will have full access to S3 service. So if you write an application to say upload pictures to an S3 bucket and embed it in this EC2, this instance will be able to upload the pictures to that S3 bucket without any issues. Remember why this is the most recommended way. Because first, it has temporary credentials, and second, it does not store any password or access key information on the instance. Now let us go ahead and look at some of the most important points to remember about IAM role. Just like IAM user and IAM group, you can attach policies with required permissions to IAM role. IAM role allows you to delegate access with defined permissions to trusted entities without having to share the long-term access keys. And how do you assume an IAM role? Well, you assume an IAM role by calling the AWS Security Token Service Assume Role APIs. In other words, assume role with web identity, and assume role with SAML. These APIs return a set of temporary credentials that applications can then use to sign requests to AWS Service APIs. This is more of an advanced topic which we will discuss later, but just keep this in mind. You can only associate one IAM role with an EC2 instance at this moment. You cannot associate more than one IAM role with an EC2 instance. This limit of one role per instance cannot be increased. If you delete an IAM role that is associated with a running EC2 instance, any application running on that instance that is using the role will be denied the access immediately. Although a role is usually assigned to an EC2 instance when you launch it, a role can also be assigned to the instance that is already running. You cannot add an IAM role to an IAM group. IAM roles cannot make direct requests to AWS services. They are meant to be assumed by authorized entities such as IAM users, applications, or AWS services such as EC2. And finally, IAM roles are free of charge. There is no cost associated with creating any particular role. In this video, we learned about IAM role, its features, and why and when it should be used. Please remember that IAM role is a very important topic for both associate as well as professional level exam. So ensure that you read all the FAQs on this topic before appearing for the exam. I will see you in the next session. Thank you. In this video, we are going to see some of the best practices when it comes to using and configuring the IAM service. First, always lock away your AWS account root user access keys. The access keys for your AWS account gives full access to all your resources for all AWS services, including your billing information. Therefore, always protect your AWS account access key just like you would protect your credit card numbers or any other sensitive secret. As much as possible, you should stay away from using your AWS account root user credentials to access AWS and never give your credentials to anyone else. Instead, always create individual users for anyone who needs access to your AWS account. If you allow users to change their own passwords, require that they create strong passwords and that they rotate their passwords periodically. You can use the password policy to define password requirements such as minimum length, whether it requires non-alphabetic characters, how frequently it must be rotated, and so on. Change your own passwords and access keys regularly and make sure that all IAM users in your account do that as well. That way, if a password or access key is compromised without your knowledge, you limit how long the credentials can be used to access your resources. Remove IAM user credentials, that is password and access keys, that are not needed. Similarly, if a user does not and will never use access keys, there is no reason for the user to have them. Passwords and access keys that have not been used recently might be good candidates for removal. You can find unused passwords or access keys using the console, using the API, or by downloading the credentials report. For extra security, enable multi-factor authentication, that is MFA, for privileged IAM users, that is users who are allowed to access to sensitive resources or API operations. With MFA, users have a device that generates a unique authentication code, a one-time password or an OTP. Users must provide both their normal credentials and the OTP. The MFA device can either be a special piece of hardware or it can be a virtual device. For example, it can run in an app or a smartphone. Instead of defining permissions for individual IAM users, it's usually more convenient to create groups that relate to job functions, such as administrator or developers or accounting, etc. Next, define the relevant permissions for each group. Finally, assign IAM users to those groups. All the users in an IAM group inherit the permissions assigned to that group. That way, you can make changes for everyone in a group in just one place. AWS recommends that you use the managed policies that are created and maintained by AWS to grant permissions whenever possible. A key advantage of using these policies is that they are maintained and updated by AWS as new services or new API operations are introduced. But also keep in mind that the custom managed policies are more flexible and hence you need to ensure that those policies are defined absolutely well and in secure manner. To the extent that it's practical, define the conditions under which your IAM policies allow access to a resource. For example, you can write conditions to specify a range of allowable IP addresses that a request must come from. You can also specify that a request is allowed only within a specified date range or time range. When you create IAM policies, follow the standard security advice of granting least privilege, that is, granting only the permissions required to perform a task. Determine what users need to do and then craft policies for them that let the users perform only those tasks. Always start with a minimum set of permissions and grant additional permissions as necessary. Doing so is more secure than starting with permissions that are too lenient and then trying to tighten them later. When you review a policy, you can view the policy summary that includes a summary of the access level for each service within that policy. AWS categorizes each service action into one of four access levels based on what each action does, that is, list, read, write, or permission management. You can use these access levels to determine which actions to include in your policies. Never share security credentials between accounts to allow users from another AWS account to access resources in your AWS account. Instead, always use IAM roles. You can define a role that specifies what permissions the IAM users in the other account are allowed. For example, applications that run on an EC2 instance need credentials in order to access other AWS services. To provide credentials to the application in a secure way, always use IAM roles. And finally, you can use logging features in AWS to determine the actions users have taken in your account and the resources that were used. The log files show the time and date of the actions, the source IP for an action, which actions failed due to inadequate permissions, and more. Logging features are available in Amazon CloudFront, CloudTrail, CloudWatch, Config, and S3. For the examination, please remember that the questions will be scenario based and most of them may have more than one possible answer. You should always be selecting the best answer, and for that, it is very important that you keep these best practices in your mind. In this video, we are going to summarize what we learned in this whole IAM section. First, we saw the definition of IAM and what it is used for. We also got introduced to the AWS console where we covered the different options AWS offered via the IAM service. One of the most important things we learned about IAM was that IAM is a global service and not tied down to any particular region. We also learned about the sign-in link and that it contains your 12-digit account ID by default. You can customize this link by creating an alias. We also ensured that all the security checks were done. Then we created individual users and assigned IAM policy to them. We also created different groups, assigned IAM policy to them, and then added those users back to those groups. We learned that IAM policies contain permissions to access AWS services and resources. IAM policies can be attached to IAM users, IAM groups, and IAM roles. We also learned about the different IAM policy types, that is, identity-based and resource-based policies. We also studied the differences between them. We also saw how IAM managed policy is different than a customer managed policy. We then studied the template of a typical IAM policy, which contains version, statements, effect, action, resource, principle, and condition. In a separate video, we studied about IAM roles. Remember that creating a role is always more secure and hence preferred over creating individual users. IAM roles give temporary credentials for access where IAM user has long-term credentials. And finally, we learned some of the most important IAM best practices. These are very important for the exam. Now, before we sign off this IAM section, I highly recommend that you do following things while you are studying as well as before taking the final exam. First, read on how IAM works. You can visit the given link for more information on this. Always read the latest FAQs. Solve all the associate level questions on this topic